Problem number 14. This is a review of finding trig values by hand. We want exact simplified answers. I need to draw the angle in standard position. So negative pi over 6, that's negative 30 degrees, so somewhere around here. And then I can drop a perpendicular. And of course, if I'm doing this by hand, it must be one of our special triangles, and it is. It's just a 30, 60, 90 triangle. I know the sides are 1, root 3, and 2. Do I have any negatives? Yes, the 1 would be negative because it's downward. And then I can just use SOHCAHTOA off that reference angle there. Here's the reference angle. Sine is opposite over hypotenuse. That's going to be negative 1 over 2. The second example is a quadrantal angle, so we'll use the unit circle. Pi is right here. That's the point negative 1 comma 0. The cosine function gives you the a coordinate on the unit circle. So cosine pi would be negative 1. Letter C, tangent of negative pi over 3. Negative pi over 3 would be negative 60 degrees. So something like this. Pick my point, drop my perpendicular. Of course, this is another 30, 60, 90 triangle. This time the 60 is the reference angle. 1 opposite the 30, root 3 opposite the 60, 2 for the hypotenuse. The negative would be here since that's a downward direction. The tangent value is opposite negative root 3 over adjacent, which is 1. And when I simplify this, I just get negative root 3. Problem number 15 asks us to write down the inverse function we came up with back in problem number 3. When the original function was 2x minus 1, we said that the inverse function would be x plus 1 all divided by 2. Now we're being asked to make some calculations. So I want to find g inverse of g of 5. I'm going to have to start on the inside and work my way out. So let's see. G of 5 means go to the g function, stick in 5. Well, that's pretty simple. I get 10 minus 1 is 9. So g of 5, this thing right here, is equal to 9. Now I'm supposed to go to the g inverse function and stick in the 9, the answer we got. Well, that's going to be 9 plus 1, all divided by 2. 10 divided by 2 is 5. Letter B, this time we're starting with the inverse function. So I want to take the 19, rather the negative 19, and stick that into the inverse function. Negative 19 plus 1 divided by 2. Let's see, negative 19 plus 1 is negative 18. Divided by 2 is negative 9. So we just figured out this part, g inverse of negative 19. I want to take that red box answer and now stick it into the g function. In other words, I want to go to the g function and I want to evaluate it at negative 9, my previous answer. Well, that's just going to be take 2 times the negative 9 and subtract 1. 2 times negative 9, negative 18, minus 1 is negative 19. Now, if you look at what happened in both of these problems, in the first problem, we started out with the number 5 and we ended with the number 5. Then we started with negative 19 and we ended with negative 19. Why does that make sense? Well, because functions and inverse functions reverse each other. In other words, whatever the original function does, the second function, the inverse function, just undoes it. It just brings you back to where you started. Problem number 16. So I'm given a trig statement, sine theta equals negative 2/5. I am told what quadrant theta lies in. I want to find another trig ratio for that same angle. Notice that I'm never asked here to actually find the angle, and I don't need to. We're going to do this entirely by hand. I'm going to quadrant 4, where I will draw myself a reference triangle picture, always with the perpendicular extending to the x-axis. Now, I'm not sure if theta itself is a positive angle that comes around here, or a negative angle that comes here, or if it spins around a few times. It doesn't matter. This angle is the reference angle for theta, and that's all I really need to worry about. The sine value is opposite over hypotenuse. So I know how to label my picture. The negative 2 on the vertical leg and 5 for the hypotenuse. Well, I can find any of the 6 trig functions by simply filling in the rest of this picture, and I can do that using the Pythagorean theorem. I have a squared plus negative 2 squared equals 5 squared. In other words, a squared plus 4 equals 25. A squared then is 21. Square root both sides. Now be careful, when you square root both sides, you do have 2 possible answers, the plus or the minus. I can see though that that a is a positive length. It's moving to the right, so I will choose the plus. This is positive root 21. Well, I just want the cotangent ratio. Cotangent is the reciprocal of tangent, so it's going to be adjacent over opposite. That's root 21 over negative 2. I'll put the negative out in the front, and here then is my final simplified answer. Problem 17 is very similar. We're just using letters instead of numbers. It says tangent theta is m over p. Theta this time lies in the first quadrant. So I'll make my triangle picture in the first quadrant, dropping my perpendicular. The tangent ratio for angle theta is opposite over adjacent. So m here and p here, m over p for the tangent ratio. I want to find another of the trig ratios. And again, I can easily do that as long as I know all the sides of this triangle. This time I'm missing the hypotenuse, but I can get it using the Pythagorean theorem. I'm not going to get a number. I'm going to get a little expression here. P squared plus m squared equals that hypotenuse squared. I can solve for the c in just one step. Square root both sides, plus or minus. Of course, hypotenuse is always positive, so I choose the plus. This side is equal to the square root of p squared plus m squared. I have no way to simplify this any because of that plus in the middle. Let's see, I want the sine ratio. The sine ratio is opposite over hypotenuse. So m over that big square root. Normally we rationalize our denominators, but that's only really important if you're dealing with numbers. When you're dealing with the formulas, there's not really any benefit in doing that. And so this would be considered a simplified final answer.